Hello friends, today we are going to solve this problem, divisible sum pair. Let's try to understand the problem statement. Given an array of integers and a positive integer k, determine the number of ij pairs where I less than j and ar of I plus ar of j is divisible by k. Okay, let's look into the example. 1 2 3 4 5 6 are these array elements and k is 5. Then okay, let's write it down. 0th index, first index, second index, third index, fourth index and fifth index. This is an array. Now what is expected is ar of I plus ar of j is divisible by k. So how to find it out whether a number is divisible or not? That is nothing but using modulus operator, percentile. Okay, so what we will do here, we have to find out the pair, right, depending upon this condition. If this condition satisfies, then only we can consider I and j as the pair. And here we have to determine the number of pairs possible. Okay, that means we have to take one counter variable. Okay, and here this is very simple program. We have to traverse this array, okay, from I 0th place, and now we have to compare this plus this element percentile k. If it is 0, then these two will become a pair. Okay, likewise first we have to consider this and this element, after that 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 this and this element. Once all the elements are traversed, after that we have to increment I. Okay, now you observe first 0th element with first element, then we are considering 0 with second, then 0 with third, likewise. So let's take one more variable j. Okay, and here we are saying ar of I plus ar of j percentile k, which is equals to 0. If it is equals to 0, then we can say what? We can increment the counter. Okay, let's increment the counter. This is the logic. Okay, so I should begin from 0, then j, in each iteration j should increment, j should become 1 2 3, then 4, then 5, right? And after that, once all the elements are traversed, after that I should increment to 1 and j should point to next element. That means while this will be the I and j, I is 0, j is 1, then we are keeping I constant, moving j, right, j2, then j3, then j4, right, 0 0 0 0, correct, and also j5. There are 6 elements, right? While I is 1, I is pointing, let's say I is pointing here. At that point of time j should point to 2, right, I1 j2, then I will be constant, j should increment 3 4 5, keeping I constant, right? And then it will become, I will become 2, then j will become 3, then 2 4, then 2 5. Okay, this is I and j. I hope you understood the logic, right? From I, each element we have to traverse, we have to find out the pair, and depending upon this condition we are making the pair. If ar of I plus ar of j percentile k is 0, then we are saying it is a pair. That's why we are incrementing the counter. Okay, I is ranging from 0 to 5, but j should be I plus 1, right? Here see, I 0, j is beginning from 1, after that j is incrementing. That is happening inside the inner for loop, right? And after that we are incrementing I to 1, then j is becoming what? I plus 1. Okay, that's what we are going to do right now. Let's do 2 for loops. Integer I equals to 0, and we have to iterate up to what? Array dot size. This is ar is nothing but a vector of integers. Okay, and then plus plus I. And after that, one more for loop we have to consider. From j equals to not 0, this should be I plus 1, right? And j should less than AR dot size, correct, plus plus j. Now what we have to do, we have to check if AR of I plus AR of j percentile k is equals to 0. We should keep this within parentheses, okay, because first we will add, after that we will take the modulus. If it is 0, then we found a pair, so we have to increment the counter. Let's declare the counter variable. This is counter 0, and finally return the counter. That's it. Let's run the code and test. Now submit the code. Okay, let's see what about other test cases. Yeah, everything is working fine, but one more thing I would like to tell you here. Time complexity of this implementation is O(n) square, right? This is n times and this is n times, right? N of n, that is n square. But how to implement it using O of n, that is your assignment. Apart from this, let me to use STL algorithm here. Instead of doing this, okay, let me to comment it out. We can directly use STL algorithm to find out this count. There is one algorithm known as std countif. Okay, countif. How it is working? First we have to pass the begin iterator. What is begin iterator? See, now I is pointing here. Okay, this is our outermost for loop. Now what we will do, whenever I is pointing here, at that time we are comparing or we are considering rest of the element except I. Okay, so what we have to do, we have to count the pair. Okay, so how you are going to count? From here, this will be our begin iterator and up to this, right? So in countif, we have to pass this begin iterator as this. So how to find this iterator? Array.begin will give us this, right? Plus 1 will give us this. But thing is, whenever I is pointing to very first element or 0th index, at that time begin plus 1 will work. But while I is pointing to this place, at that time it should point here, right? These elements we have to consider, correct? So that's why what we have to do, we have to say begin iterator plus position of I and plus 1. In that way we can use countif. Okay, let me to write it out here. Array dot begin plus I plus 1. Whatever the position of I, we have to consider the next element, right? In the very beginning I is 0, that's why it will become begin plus 1. That is perfectly fine. Then end iterator. That end iterator, you know, that is array dot end, and after that we have to pass a predicate. This predicate decides whether we have to consider or not. Okay, it will ultimately return true or false kind of instruction. Let's write it down, the same logic here. To this function, let's pass one number, because what it is doing, from begin to end, begin plus I plus 1, from this position to end position, it will read each and every element and pass one by one inside this function, okay, inside this lambda. That's why we are taking int n, and we are capturing it using n, and here this should be n plus, right, n plus array of, then percentile k equals to 0. If it is true, then just return true, otherwise return false. You can also use ternary operator, and here we are getting some error because AR, here it is just a parameter to this function. So what we can do, we can capture in this capture list, we can pass it as a reference, or we can also use equals to, it will do a copy. Okay, let's use reference. That's it. And what it will do, it will return the count. Okay, let's collect it inside the count. But in each iteration we have to consider the previous count also, right? That's why it should not be count equals to, it should be count plus, that means count equals to count, previous count, plus whatever the current count. Okay, why it is showing me count if error? Let's see the error, spelling mistake, count if. Let's run it. And again, if you want, you can use ternary operator instead of if else. Just remove. Okay, let me to remove it. If this condition is true, then return true, otherwise return false, and here write the return statement. That's it. Perfect. Let's submit the code. Submit the code. Matching parenthesis. Yes, it is correct. Yeah, all test cases are working fine. Just by looking into this code, someone may think time complexity of this problem is O of n, but actually it is not true, because this count if is also O of n. So this is n of n square. I hope you understood how to solve this kind of problem, divisible sum pair, and how to use count if. This is STL algorithm. Okay, see you soon in our next problem solving session. Thank you.